All right, everyone, let's do some similarity assignments. We're going to cover P1, 2, 5, 8, 10, and 12 from IXL. So hopefully that's helpful. And let's start by looking at the similarity sign. This little squiggle, that in geometry means similar. And that, the meaning of similar is, I'd just say same shape. Okay, so that's, there's more precision that we will talk about, but the idea you can have in your head is same shape. And what does that mean? Well, it means congruent angles and proportional sides. So like if the sides are proportional, then one shape could have sides that are 4 times as big or 5 times as big. And we do have to set up proportions, which is a fraction equal to a fraction. And so there will be a lot of cross multiplying when you have similarity because of the proportions. So lots of that. So let's look at the similarity ratio of these two quadrilaterals. You can see that they are both trapezoids, apparently trapezoids, and looks like one is flipped upside down. Based on these angles, the two S and T correspond to E and F here. So that means that that side and that side correspond ST and EF. So if those are corresponding sides, then we can divide their side lengths, which would be 14 over 7, which is 2. Tells us that this trapezoid is times 2, right? And then we should see that on every side. So if I look, sides are 28, 14, that's times 2, right? And then that 30 and that 15, that's 15 times 2. So we know that the similarity ratio is 2. Similarity ratio 2 times 2 to 1, or something like that, All right. This says right as a fraction, a proper fraction, improper fraction, or whole number. So I would write 2. Oh, but let's see, let's make sure that where it says RSTU. Oh, well now listen, we gotta be a little bit careful because this is the double one and that's 2. This is 1. So it's 1 to 2. So I would say 1/2. So just be careful with that. Okay, the two triangles below are similar. Write a similarity statement. And a similarity statement is not like, these two triangles are similar, period, end of story. Although I have had students write things like that on a test. The similarity statement is this thing right here. We wrote congruent statements for triangle congruence, and now similarity statements, same thing. Make sure the letters are matching. Okay, so the vertices should correspond. This one is really easy because the triangles are turned exactly the same way, just one is bigger. So H corresponds with B. Okay, so B, C, D. But if they weren't like exactly like that, we would just look at the angles and make sure that the angles matched up. All right, so that's that one. Some of these, there's 6 assignments, but some should be easier and some more challenging. Okay, so let's talk about Whitney. P5 is talking about indirect measurement, one of my favorite things in geometry because it's so easy to actually use. Okay, so we're going to draw a picture. Whitney wants to know the height of an ash tree. So here is Whitney. Hi, Whitney. How are you? Okay. She is really thinking about how tall is the tree. She measures the shadow of the ash tree. Okay, let's draw our tree. Have one of the little holes for the owls to have their home. All right. Okay, there's our tree. And the shadow of the ash tree is 15 yards long. 15 yards. Whitney knows that the nearby monument casting shadow is 32. Oh, so she knows that there's this monument. A monument. I wonder what the monument is a monument of. Maybe a little guy up here from the past that we want to recall some famous person, and it's a monument. Or anyway, the point is that we know the monument is 32 feet tall, and the shadow of the monument 60 yards. So this is 32 yards. Okay, good. So all our units are the same. So we don't know how tall the tree is. Sometimes people measure their own shadows, which is why I have Whitney there, but she's just looking at this stuff. So how tall is the tree? Well, both things are having shadows cast on them by the sun. So the sun's rays kind of make this little triangle. You don't need to draw the triangle, but what you need to know is that these are proportional shapes. So we can set up a little proportion. So it's just going to be, just put the corresponding sides in the same spot. So my two vertical sides and my two horizontal sides. I'm just going to write x over 15 equals 32 over 60. So I got my two verticals on top, two horizontals on the bottom, and now boom, boom, cross multiply. 60x equals, now what is 32 over 32 times 50? And you got this fancy dancy graphing calculator to do some simple arithmetic. 480. All right, well now I'm not going to use the graphing calculator this last one. So that 8, x equals 8. That means the ash tree is 8 yards tall. So you can do that. You can measure your shadow. You can know how tall you are. You can measure the shadow of a building or a big tall thing. And then you can use some geometry and calculate how tall it is, even though you could never measure it, you know. And that is cool. All right, so now P8 is connecting similarity and transformations. So similarity is really just dilations, right? Size changes. You can transform EFG to E prime, F prime, G prime by translating it and then performing a dilation centered at the origin. So EFG, triangle EFG is similar to triangle E prime, F prime, G prime. Find the translation rule and the scale factor of the dilation. So we would have to, so it says we can translate it and then dilate it about the origin. So the first thing is we want to, well, I sure do wish that we would, okay, so if the origin is our center, then E prime is right there at the center. So E is down here. You know, if I moved it, I would be moving it down 9. It's down 9. And then this is 3. Okay. So it looks like the translation to get from E to E prime would be -9 minus 3. X minus 9, Y minus 3. Okay, now what's the scale factor? Well, the scale factor is not too hard. All we have to do is find the distance of two corresponding sides. So G is at -6, F is at 9. So GF has a side length of 15. And how about G prime F prime? That goes from -3 to 2, so that's 5. So we can see that it's 5 over 15, which is 1/3. So that blue triangle, the image is 1/3 as big as its original pre-image. All right, let's move on. We got 2 more. And so after you get done with that one, you know, you might be a little bit like, oh, that was difficult. But then this one should be simple. So PS, we want to find that. So, well, where's PS? PS is this whole thing right here. Okay, so let's put an X there. So, you know, we could do this in 2 ways. We can find ST and then just add them together, or we could set up a different proportion where we add P, Q, and QR together and then do that. Well, let's do that because I bet that's the one you might not be thinking of. So, so I'm going to write it like this: PS over TP is PS over TP is equal to PR over QP. It's a weird way to write it, but it's true. All right, and that's because of these parallel lines, so that they make this proportional. Parallel lines cut a triangle proportionally. Well, a line parallel to the base does. So now, PS is our unknown. TP is 44. PR is 30. You got to add these two together. And then QP is 20. All right. 3 over 2. So 2x equals, what's 44 times 3? It's 132. 132. Divide by 2. Divide by 2. I'm so lazy. 66. That means x is 66. All right, so just some cross multiplying. I forgot to draw my arrows. Boom, boom. So I got that. Okay, last one. So when you have similar figures, we have, you know, like we just did, setting up proportions between the sides. So the sides are proportional. The sides are proportional. The perimeters are proportional. The angles are congruent. This is similar figures. The properties of, right? We got proportional sides, we got perimeters that are proportional, angles that are congruent, and the areas, they're proportional too, but we got to square it. So that can throw some people off. So we got to square the scale factor and multiply by that. Okay, so what does that look like? If the area of this is 4, and then the area of this, and you, okay, so what we want to do is we want to say that this triangle is 9/2. So it's bigger, right? So 9/2 is 4.5. This triangle is 4.5 times as big. That means the area of the triangle is going to be 4.5 squared times as big. You have to square the scale factor, 20.25. Okay, so this is the scale factor, and this is the scale factor squared. So when you're talking about area, because we have the 2 dimensions multiplied together, the scale factor ends up being squared. So we're going to have to multiply 4 times 20.25, 81. So if the one, and look, 9 squared is 81, so that's nice. But that is the bigger idea. If you got a scale factor that relates to figures, like one figure is 3 times as big, then the area of that figure is going to be 9 times as big, 3 squared. All right, so go ahead and post any questions you have on Google Classroom. Like and subscribe to Mr. Fields' YouTube channel, and I'll see you in class.